Application of linear equation, initial position and rate of change. Our focus has been on initial position and rate of change when we are relating to linear equation, which is y equals to mx plus b. Now in y equals to mx plus b, m is the rate of change and b is initial position, correct? Now let's look into this problem. It's like full paragraph. So a lot of things to read and digest. So we'll go really slow on this. Runner, soldier and fighter are security guards stationed at different locations within the same building. So there are 3 security guards in the same building. Suddenly, they hear an alarm. Soldier takes his position. Fighter runs at 6 meters per second towards the main entrance while runner runs away from the main entrance at 7 meters per second. After 10 seconds, runner is 75 meters away, soldier is 25 meters away, and the fighter is 30 meters away from the main entrance. Determine the starting position, distance from the main entrance, and the linear equation of the form y equals to mx plus b of each security guard. Correct. I hope you understand what this question is talking about. So let's elaborate. So let's read it once again. So there are 3 security guards. Runner, soldier and fighter are security guards stationed at different locations within the same building. Let's give them short forms. Runner, soldier and fighter. So these are 3 security guards which are stationed somewhere in the building. We don't know how far they are from the main entrance, correct? Suddenly they hear an alarm. Soldier takes his position, means stays put. So soldier stays in the same position. Fighter runs at 6 meters per second towards the main entrance. That means when fighter is running 6 meters per second towards the main entrance, then the distance of fighter with main entrance is decreasing, correct? So this should be negative distance, right? For fighter, so we can write an equation for fighter as minus 6x, right? So with time, which is x, distance is decreasing towards the main entrance, while runner runs away. So runner runs away from the main entrance at 7 meters per second. So for runner, it is 7x. Distance will increase because runner is running away from the main entrance at 7 meters per second. Do you see? And soldier stays there, so it is times 0x. Soldier is not running, correct? After 10 seconds, runner is 75 meters away. So we don't know their initial positions, right? But we know their positions after 10 seconds. It says after 10 seconds, runner is 75 meters away. So runner is 75 meters away. So this is after 10 seconds. So we'll write here after 10 seconds. Let's say t is or x equals to 10 seconds. Then runner is 75 meters away. Soldier is 25 meters away. Soldier is 25 meters away. And the fighter is 30 meters away. The fighter is 30 meters away. So all this is the position after 10 seconds, right? Determine the starting position. So we don't know their starting positions. So let's say the starting position for runner is R, the starting position for soldier is S, and the starting position for fighter is F, right? These are their initial values, the starting position. What we know is after 10 seconds, this is their new positions, right? Determine the starting position, that is these, distance from the main entrance, and the linear equation of the form y equals to mx plus b of each security guard. So we kind of got both the things, linear equation as well as the starting position, right? So let's find the starting position for each. So after 10 seconds, the distance is 75. That means if I put x as 10, I get 7 times 10 plus r. These are my initial positions, which I need to find, right? So let's try to find these positions. So after 10 seconds, so I'll write is 75 is equals to 7 times 10 plus r, right? And for the soldier, since soldier didn't move, it is 0 speed times 10 plus soldier. And for the fighter, it is minus 6 times 10 plus fighter's position. These are initial positions, correct? Now from here, we can calculate 7 times 10 is 70. Now 70 plus 5 is 75, correct? 70 plus 5 is 75, or you can calculate r from taking away 70 from 75. So that gives us value r is equal to, so let me write, r is equals to 5. Now here soldier, this is 0, is same as 25. So soldier's initial position is same as it is given, right? Because soldier didn't move and the fighter moved towards the main entrance. So his original position was farther away. So it is minus 60, and when you take it on this side, it becomes 30 plus 60. That means fighter's initial position is 90. So these are the initial positions for the 3 security guards, right? Now once we know initial positions, we can write our equation, correct? So we have to basically substitute this value here. So our equation in terms of y equals to mx plus b will be, now let me write down here. So we got y, this is for the runner, 7x runs away and therefore the distance increases, plus 5, correct? For the soldier, it is equal to, it stays same, which is 25. S is 25. And for the fighter, the equation is minus 6x and initial is 90 plus 90. Do you see that? So these are our y equals to mx plus b or linear equations to represent the position of each guard with time, right? Position, time position, right? Now you can check your answers. If x is 10, do we get 75? Right? So our value was 75 here, right? So 10 times 7, 70 plus 5, 75. X is 10, there is no x, it is always 25 for soldier. So 25. And if it is 10, then 90 minus 60 is 30. So these are the correct answers, correct? So that is how you're going to solve such a problem, right? It is kind of tricky, so go through it once again and try to understand what we did. Thanks and all the best.